So there's no drill next week?
No drill on Friday next week.
You know when the homework things will be up?
What's that?
The homework keys.
I posted the first homework key, and I'll get the second one up this evening. I won't get down to Little Rock until probably 7 o'clock or so it'll be later tonight before I get it done, or tomorrow morning maybe. So today we're gonna talk some about dummy coding, but we're gonna also do some orthogonal contrast stuff, a little bit with interactions. On this week's homework, I'm waiting to hear back from Patrick. There's one small section that we'll briefly talk about, but I told him that he should cover, basically it's when here's the linear model, that's your output, like, find the simple effect of whatever at this level of whatever else and how all that works with interactions between, factors and things like that. So I'm suggesting to him that he cover that in in lecture on Monday. So if I leave that on there, unless I hear back from him, just to take that part off the homework, then don't freak out when you look at the homework and see that is one of the questions. Be like, we haven't talked about this. You will before it's due. But that said, I guess we'll just go ahead and get started with this. We're going to go back to the Prestige data set initially. So just as a reminder, we have this type variable. It's either professional white collar or blue collar. Here I'm creating a copy of type and calling it type D, just so that later on when we do something for demonstration purposes, we have just an exact copy of the original variable that hasn't been modified. As far as the way that Patrick names everything like C1, C2, C3 and refers to everything as contrasts. If y'all recall, back at the beginning of last semester, there was some confusion about the terms used for things. He likes to just call everything contrasts, but technically dummy codes is a specific type of contrast coding. And then I had mentioned before effects coding versus these other specific names, whereas he just likes to call everything contrasts. What I'm getting at is that what you may see, if you're just looking online, is that some people, when it's dummy coded, instead of calling it, just C1, C2, they would code it as D1, D2, or if it's effects coding, which is another type of coding scheme, using E1, E2 as your labels and that sort of thing. So just throwing that out there in case you're looking up stuff and seeing other naming conventions. Just keep in mind that Patrick calls all of these things contrasts, which they are, but there are, specific cases of contrast that sometimes carry these other labels. But anyway, so we have, if you check out the summary of type, basically it will give us just our counts. Whereas if you check out the summary of some numeric variable, it gives you, min, max, et cetera, et cetera. If we run describe from the psych package, just keep in mind those asterisks are telling you that type and type D are factors. I'm going to go ahead and take out those 4 NAs just to simplify things downstream. So remember that factors have the 2 primary attributes, the text labels that give you the names of the levels of the factors, and that numeric, the matrix of numeric contrast codes that are used. And you can check these things again by using levels and contrasts. So when we run levels, we can see that the levels in order are blue collar, professional, white collar, and by default, our contrasts are dummy coded with that first group as the reference category. So if we hypothesize that professionals will have higher prestige in society over other occupations, but also that white collar workers will have higher prestige than blue collar workers, we would make these two contrasts. The first contrast we'll be comparing professional occupations to the average of blue and white collar to see if they have that higher prestige. And then the second contrast being comparing white collar and blue collar. So this is just kind of a refresher basically of what we've already done last week. And so, one way of doing this is using the VAR contrast and POCs, and we tell it in our first contrast, we code blue collar and white collar as -1 and professionals as 2. And then in the second contrast, put professionals as 0 and blue collar and white collar as -1 and 1 respectively, and give it the labels C1 and C2. So now when we run that, and if we look at our contrast, we can see that it's no longer dummy coded. And then we can fit this type factor instead of using the C1 and C2, just regress prestige on type. And when we look at our summary, we can see that it gives us, when for our first contrast and our second contrast. So when looking at these two things, what does that intercept represent? Well, prestige is the DV here. Correct. Yeah, because we're using those orthogonal contrasts. So the intercept is going to be the average of all the groups. And then how do you interpret this estimate right here in the significant difference for C1?
Professional jobs have prestige that is 28.96 units, however that's measured, greater than the average of white collar and blue collar workers.
Right. So we got the comparison between the two groups as they're coded, the professionals versus the average of blue and white collar together. Professionals have 28.96 units of prestige higher. And then for C2, same thing, but now the two groups that are being compared is blue collar versus white collar, and they are 6.7 units apart in prestige. Now, one difference between using the where you put the contrast as the factor itself and then regress prestige on type instead of prestige on C1 plus C2 deals with when you're looking at model effect sizes. So we'll see the other here in a minute. So when we look at our model effect sizes here, you'll notice that all it does is give us the overall R squared. It doesn't give you the change in R squared from C1 to C2. Whereas whenever you do have something regressed on C1 and C2, whenever you check that model effect sizes, it'll give you the effect size for C1 and then the delta R squared for C2 as well, which we'll see that in just a minute. And so here I'm just going to create that C1 and C2 using the VAR regressors, which as a reminder that it will take whatever contrast you've stored as on that factor and use that to create your two actual columns. So now when we look at our data frame, we can see that we have C1 and C2 put in there. So if I go back and run on this line right here, all I'm doing is I'm using that original type D, the one that we didn't modify at all, just to show that by default, it's dummy coded. So you have to make sure that you store your contrast before you use that VAR regressors if you're trying to create those additional columns. And so now if we run the exact same model, but instead of regressing prestige on type, we regress it on C1 plus C2. When we look at our model summaries between these two, you'll see that the model summaries are identical. There's no difference here in type regressed on prestige versus type regressed on C1 or C2. But where you do find a difference is when you look at those model effect sizes. Like I said, when you have prestige regressed just on type, all it's going to do is give you your model R squared. But here it'll give you that delta R squared, the difference between C1 and C2. So depending on what it is, what information you're trying to pull out of it, you may need to do it one way versus the other. Yeah, what's up?
Clarification. Your bar contrast assigns specific contrast codes to a variable in your data set. And then your bar regressors creates two new variables that are the contrast codes that you have previously assigned to that variable.
Yeah.
To the last variable.
Yeah, so that's, if we look at, so if we just look at our contrast for, this is after we, up above where we use bar contrast, and then we have the assignment operator and assign that to contrast DF type, so that like R saves that contrast coding scheme as the contrast for that. So that's what R will use. But for the type D, the one that we didn't mess with yet, since by default it's dummy coded, if you use bar regressors with type D up here, then instead of having a column with, you know, things coded as -1/3 or +2/3 or -half, +half, 0, it will just have those columns coded as zeros and ones, and it will dummy code it for you. So whatever is the underlying, you just have to remember to check your contrasts to make sure you know how it's currently, how R is representing that particular variable.
And you can't get your extra effect size for the other contrast
without putting in the individual, yeah. So then for plotting, you know, nothing new here. Any questions over that? How are y'all feeling generally about like contrast and the stuff that we've been covering so far? Is a lot of it, you know, making sense? I mean, it's just a slight departure from what we worked on most of last semester. There's a little bit of interpretive differences that you have to kind of stop and think about sometimes, but it shouldn't be anything, you know, wildly different and unusual.
The only thing that took me up on the homework was sort of making sure I read the specific hypotheses correctly. If you make a little mistake on that, it messes up the whole process.
Yeah, and that's often the difficult part with contrast, is making sure that you are understanding those specific hypotheses correctly. I'll try to make sure that the specific hypotheses are clear as far as in the homework, in the little study description, like I have in parentheses, like researchers suspect that H1, this group will blah, 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 but also H2, like this group, blah, blah, blah. And really all you got to do, all you have to do is, you know, think through it, I suppose, and just really think like, okay, which groups am I comparing? Like, what am I ignoring for now, and working from there. And then like I mentioned last week, there's a finite number of possible like coding schemes for orthogonal contrast, depending on whether you have 3 levels, 4 levels, 5 levels, etc. So worst case scenario, with some Googling, you can find like a generic thing that says for a 4-level thing of A and B, like here are orthogonal matrices of things. And you can think through like how that maps onto whatever your variable is, and like what type of comparisons you're making there, which is with the like the chocolate thing. which it was after I was planning on posting the homework last Thursday. And then once I got back to my office, I realized I wasn't paying attention, and I took the problem from the homework and put it in the drill as like the work through in class exercise. So I had to sit down and completely redo the homework, and that's where I ended up pulling this chocolate stuff from. But I reverse engineered that entire problem, and I started with an orthogonal matrix, and then thought like, okay, now how could I set this up to where I'm asking these specific questions to make sure that, you know, the answer is this orthogonal matrix. And so just depending on it, if you're looking for something that's orthogonal, there's only a finite number of ways that you can possibly code it. And then you just have to think conceptually, how does that map onto the problem that you're looking at? All right, dummy codes. So again, whenever you're looking at dummy codes, which is the default, so when we look at our levels, we see that we got blue collar as the first level, and that first level will always be your reference level, which now means that in your output, the slopes are telling you the difference between whatever group is coded as 1 and that reference group, and your intercept. You know, all year we've emphasized when you're looking at a regression output, just think the intercept is the average when everything is 0, which in the case of dummy coding, the only time that everything is 0 is right here for blue collar. So in this output, your intercept would be the average of the blue collar group. And then those additional estimates are telling you how far does, if you change, you know, from 0 to 1, so professional versus blue collar, or in this case, white collar versus blue collar. So let's say though that we want to make professionals the reference group. There's a few different ways that you could do it, just depending on what's your particular flavor. One is that you could reorder the level of the factor, reorder the levels, because that order is arbitrary. They're factors, which by definition means that there is no actual order. They can be moved around. So there's the tidyverse factor package is called Forcats, and they have this FCT relevel, factor relevel. And the way that it works is you just tell it what you want to reorder, and then you tell it in what order. So here, all I did was I said type D and professional. And you'll notice, you can ignore all this up here, but you'll notice that down here it tells us the levels of the orders now, and it has professional first and blue collar and white collar. Anything that you don't put on there, it implicitly tells it, leave this in the same order and just like shift it down. So if I put professional and white collar and run this next line, now it'll put professional first, white collar second, and then blue collar. If there were additional groups, those additional groups would be left in whatever relative order they're in, and all it would do is put professional first, white collar next, and then leave everything else in the order that it was in. And so in this case, if we put, if we just run this factory level and tell it professional first and store that back as type D. Now, when we look at our levels, we see that it's stored with professional as the first level. And when we look at our contrast, which is the default dummy coding, now professionals is the group that has 0 for both.
Here, after you did the factory relevel, have that file on the last row.
Here? Here?
Yeah, see that last problem there? One line right there?
Yeah. Yeah.
Is that a problem with that?
No, that's just the order that they are in the data set. So if we look over here, it's just because these aren't all in proper order. So if we come down here, there's that one right there down around 92. So that's all. That's why I'm saying you can ignore this, because that just shows the actual data. and so that's not going to change anything. But I was just wanting to point out that where it tells you at the bottom of the output, like what the actual levels are there. Right here. Same thing accomplished by just typing in levels, type D. Alternatively, you can use the var contrasts function that we've used before, but instead of telling it POC, we tell it type equals dummy, and then we can tell it what the reference level is. So here I'm going back to the original type variable instead of that type D, since we just now changed the factor levels of the type D thing up here. So if we look at, and if we tell it to var contrast type and use the reference level of 2, ignore the fact that it outputs twice here, because when you actually store it like we will here on line 150, it'll only show it once. I don't know why it shows it twice here, but nonetheless, when we put ref level equals 2, you can see that it codes that second level with 2 zeros. If we put reference level equals 3, now the reference group is down here where we have both our zeros. And so to set that as the contrast, where we want to set the contrast where professionals is the reference group that we're looking at. And so when we run this line here on 150, we now have this put in as our contrasts. And a reminder that the whatever you put as the reference group is the group that the other group's means are being compared against. And now whenever we run a model where we're regressing prestige on type with that new dummy coded thing, you can also run this described by. You can see that the 67.85 is the intercept is just the mean of that reference group. And then your other estimates are the difference between that group and the white collar group, or that group and the blue collar group.
Can you say that?
Yeah, so because professionals is our reference group, the intercept is the mean of this group. Then that minus 32.3 for blue collar versus professional is the difference between these two means. If you just look at the difference in the average of this group and this group, they're different by, this is 32.32 points lower. And then this one is 25.6 points lower than the average of the reference group. Remember that so here's how we have our current coding scheme. Now, what would this look like if these were orthogonal contrasts? If we run these correlations here.
1, 0, 0, 1.
Right, orthogonal is non-correlated, but because these are correlated, in order to have that meaningful interpretation, you have to have all the contrasts in there. If you had 4 levels, so you had 3 contrasts, you have to have all 3 of those contrasts in the model, or you can't make that interpretation. And last week I talked a little bit about why orthogonal contrast and that uncorrelated those uncorrelated mechanical variables, and how that relates to your R squared not changing whether or not you put these things in. And so this is just conceptually the opposite of that. Now they are related, so there is overlapping variance that's explained. So when you take out one of these contrasts, you're also taking out some that's in this other one, because now they are somewhat related, which is why conceptually you won't get the same results, and you can't have this interpretability without having all those contrasts in there. But in this case, when we looked at our summary up here, we compare the blue group or the blue collar group to professionals, and we compare the white collar group to the professionals, but we have no comparison of blue collar versus white collar. And in this case, the only way to test that is to change the coding so that we can assess that. And so here, all we're going to do is change these contrasts to where now white collar is the reference group. So now when we fit this into model 3, instead of comparing blue collar professional and white collar to professional, we're comparing blue collar to white collar and professional to white collar. And now once we run this, we can look and we can say, all right, the difference between white collar and blue collar, this intercept 42.2 represents what?
The mean of white collar.
Mean of white collar. And then this estimate represents what? Negative 6.7.
The difference between the mean of white collar and the mean of blue collar.
Exactly. The difference in white collar versus blue collar. So the blue collar is on average 6.7 points lower in prestige than white collar, which is a significant difference. All right, so then let's take a brief look at some interactive stuff, which again, really isn't anything drastically different than what we've done before. But let's just say that we want to see if the different levels of type interact with income. And so we'll run this mod here, and now we have this interactive output. So just as a reminder of what we have coded how. All right, so now the intercept. Oh, that's the other thing. So just below this, you'll see where I have this option SciPen equals 2 thing. That's just a thing to tell R like how to handle scientific notation when you're dealing with small numbers. So if you run that and then come back up and run the summary, it'll, instead of having the scientific notation, it'll give you readable numbers.
What was that code again?
Down below, I have like the options SciPen equals 2. That whenever you start getting a lot of like the scientific notation stuff, you can adjust that as you need to get it to not give you scientific notation. All right, so now we have an intercept of 32.88. What does that mean?
The average prestige, the average income across the levels of type.
Yeah, well, close. I didn't mean center income, which arguably I should have beforehand, and I did. I think later in the script I said to specifically mean center in the example thing. So it should be mean centered, yes, and then you would be right that it's the average for white collar workers with the average income.
Is that 0 income then?
Yeah. And then basically, like, you can think of everything above this line right here, these first two, that's nothing different. That's exactly what we had before. But now we also have this income line right here. So what does that represent? If our reference group is white collar workers, then the line that says just income,
Is it the income, or for, white collar, or the prestige for, oh, is it how prestige changes for 1 unit increase on income for white collar workers?
There we go. That's exactly right. For white collar workers specifically, a 1 unit increase in income is related to a 0.00185 unit increase in prestige. So now this next thing, type BCBWC income, all that's telling you is that the interaction there of income for this other level up here. So for that comparison between the blue collar and white collar workers, now a 1 unit increase in income is related to a 0.002 increase in prestige. And then this third one, or this last one down here, is just the effect of income on prestige for that second contrast, professionals versus white collar.
How would you say that?
So it does 1 unit increase in income changes the relationship between professors and working class by 0.001 units of prestige.
Say that again?
So at, a 1 unit. So as income increases by 1 unit, the relationship between professionals and working class changes by negative 0.001.
Versus white collar. But yeah, so you might say something like, I guess I should have written up a summary instead of coming up off the top of my head. So the effective income on the prestige of white collar workers is that for each 1 additional unit of income, prestige goes up by 0.002. The difference in blue collar versus white collar, for the difference in blue collar versus white collar, the effect as income goes up 1 unit, the effect on prestige is 0.002. I got it right here, I suppose. And then for the difference in the difference between professional and white collar, the effect of income on the difference in prestige between professionals and white collar is non-significant. For each 1 unit increase, the effect of prestige goes down. So basically, the difference between blue collar and white collar is associated with an income difference, whereas between white collar and professionals, which they're both making more money, the amount of income that they're making isn't impacting the level of prestige that is seen in that job.
I don't know if those graphs that Patrick made with the slopes.
Mm-hmm.
would be helpful.
Yeah, and that's I've long argued for like how good data visualization helps data make sense, and that's part of the reason why we've really hammered like being able to make graphs this semester. As far as if you're wanting to make your own for those types of graphs, you have all the tools that you need to do it. It's really no different than things that we've done in the past, whether you're using, depending on what type of plot you're using, you may just use that ggPredict and be able to plot your various slopes and lines and stuff. Last semester, we also, before we started using PredictLM, which was before we started using ggPredict, if you recall, at one point we were specifically, we were using, what was it? Was it geomeline? I think it was geomeline specifically that we would use, where we were actually pulling, and we would use like coefficient of whatever, and then in brackets we would say like coefficient 2 minus whatever, and Like that's really how you're able to pull out and manually plot those prediction lines and stuff. And so, I mean, if you want to try it out, and like if you're getting stuck, if you can't figure it out, you know, shoot me an email. I'd be more than happy to help kind of point you in the right direction. But yeah, like I mean, we've made those exact same types of graphs. It's just more complicated now with, you know, 7 parameters in the model instead of 3 or 4, and just figuring out, okay, like which coefficients, if I'm trying to plot, you know, this line, like what is the slope of this line? Well, it depends. Like you have your intercept, because you have to give it an intercept and a slope, and you have your slope, but you have to figure out the intercept for any particular thing. And but if you look back through your drills, you should be able to find basically that exact setup, not the GG predict or predict LM, but back when we first started plotting the prediction lines. Any questions about that so far? All right, this is the part that I sent Patrick an email about talking about this in class, but I just wanted to kind of throw it out there since, at least as of right now, there's a problem like this on the homework where it says like you have 2 levels of factor A and 3 levels of factor B, and it's coded this way. You know, what is the simple effect of A at level 2 of type B? And really all you have to do is sit down and kind of think through various things. Like, okay, well, if I'm looking for the effect at level 2 of B, then anywhere in this linear model where it says y equals, you know, intercept plus something A plus something B1 plus something B2 plus something A times B1 plus something A times B2, and you take that linear model and you look and you'll plug in, you know, either 0 or 1 for anywhere that it says A. And then for B1, you'll plug in either 0 or 1, depending on if you're looking for level 1 of B, then wherever you see B1, you plug in a 1. Wherever you see a B2, you plug in a 0. If it's for level 2 of B that you're looking for something, wherever that linear equation says B1, you'll put in a 0. Wherever it says B2, you put in a 1. So all you have to do is kind of stop and think through it logically and look at how the coding is set up. And then you can sit and work out the math as far as like, okay, so now we sum all these up, blah, 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 and then get to our final answer. But again, I know we didn't talk about it. So I'm going to try to get Patrick to give an example of this and talk through it on Monday. Certainly if it stays on the homework, I'll insist that he does. You know, if you want to take a stab at it on your own and see what you can figure out, feel free. But that's all we're going to talk about it for today. Because instead we're going to get into this exercise. So here, all I'm doing is I'm pulling the chocolate CSV that we used last week. So here where I have this like dot in the file path, that just tells R, go from whatever our current working directory is, go up 1 level. Since our current working directory is week 2, and the parent folder of week 2 is that GLM2 folder, by saying ... week 2, that tells it to go from week 3 up to the GLM2 folder, and then down into week 2 and pull out the chocolate CSV file from last week. So that's all that's doing, just FYI. So when we run that line, we now have our chocolate data set from last week. So now we're just going to spend what time we have working on your own as groups, whatever, and let's start working through these things. First thing I want to do is once you read in that chocolate file, just to keep things a little more simple, we're only going to use 3 groups. So filter it to where it only has USA, Germany, and France in the data set. That's the location. You'll have to change the location to a factor because it'll still be in there as a character. Check the current contrast codes and think about what's being compared to what. And if it's not Germany as the reference group, then create some dummy codes to set Germany as the reference group. And then you're going to test for differences between the US and Germany and France and Germany, but also see if the percentage of cocoa in the chocolate moderates that effect. In other words, if there's an interaction, there's another variable in there that's cocoa percent, and it's just how dark of chocolate is it. Some places like darker chocolate than others. So go ahead and make that model and test that interaction and see what you find.